committees. Um, Before joining CGA in 2018, Rob spent 37 years at Praxair working with compressed gases, particularly hydrogen and other flammable gases. Rob is the chair of the technical committees for NFPA 55 and compressed gases and cryogenic fluids, and is the chair for ISO TC 58SC4 technical subcommittee on gas cylinder operation requirements. Finally, our host for today's presentation is Chris Pitosha. Chris is an Associate Director for Environmental Health and Safety here at Columbia. He is a certified safety professional with 18 years of experience and has been with Columbia since 2004. I will now let Chris begin the presentation.
Thank you very much, Paranita, and welcome once again to everyone, particularly to our distinguished panelists and guests. It's a hard act to follow, so I'll do my best. One thing that I want to point out before we get started today is that one of the new elements that you will hear me talking about of the safety program for compressed gases is a training module that is available on Rascal. And today's session is not a substitute for the completion of that module. The module goes into far greater detail on the topics that we'll introduce today. And so this morning, we're really only sharing what the new tools are, where to find them, and how to use them. That said, I hope you will find today's session to be useful as you look to navigate these new resources. So thank you again for joining. So why are we here? Well, you're all here on this call, and so the importance of safety when handling and using compressed gases should be self-evident to everyone, but just in case, it's worth pointing out that all compressed gases, and particularly those that are flammable, toxic, or otherwise inherently hazardous, in addition to their physical properties, do have the potential to cause catastrophic damage, including fire, significant physical destruction, and even fatal injury. And these things happen from time to time. There are examples of this in the research settings, including an explosion of hydrogen gas at a university in Beijing, China, and there have been other incidents, both domestic and abroad, using and related to the use of compressed gases. So with that in mind, again, this will be basic to most or all of you, and I'll keep this very brief, but just for purposes of illustrating the scope of the program, I want to take a moment to define compressed gases and refer to the basics of their hazards. So the definition that you see here, that a compressed gas is any material or mixture which exerts an absolute pressure of 280 kilopascals or greater at 20 degrees C in its packaging. That is a definition from the Department of Transportation. And it's a good definition for our purposes here, and it generally captures the materials that we are covering via this new program. And from there, I want to talk about three categories of hazards of compressed gases. And the first two are shared by all gases. The third is specific to the contents of a given cylinder. So all compressed gases pose physical hazards due to the potential energy by virtue of the compression of their contents. If those contents were released in an uncontrolled manner, bad things can happen. If the pressure in the compressed gas cylinder is released quickly due to improper storage, improper handling, due to fire or valve damage, that cylinder can become a missile-like projectile capable of injuring people or damaging property. And many have seen the clip that we've shared for years in our general laboratory safety training of a cylinder breaking through a cinder block brick wall. And there have been other examples and photographic evidence in the aftermath of other cylinder incidents of cylinders denting and damaging and breaking through metal storage cabinets. So these things are in and of themselves dangerous due to the compression of the contents. Second, very simply, most of these cylinders are quite heavy and they can be somewhat awkward as well. And so if one falls or is knocked over and lands on your toe, you will definitely know about it. So we need to be very careful about storage and handling of cylinders for that reason alone. This is something that we need to be aware of. Beyond that, we then get into, and we need to think about the chemical content of the cylinders. What kind of gas is inside? What type of hazardous properties might it possess? And the chemical hazards of compressed gases cover the same range of hazards as do other liquid or solid reagents in the lab. They can be flammable, cryogenic, reactive, toxic, corrosive, and others can be asphyxiating. And many have some or all of these hazardous properties in combination. So that's a little bit of an overview of the importance of all of this information. Again, likely self-evident to everyone who is on this call, but just to help understand the scope. So now that we're all on the same page with regards to what materials are covered in the program as compressed gases, let's take another quick moment to define who, for purposes of the program, is a compressed gas user, other than simply saying everyone who is on this call. So for purposes of the new materials, a compressed gas user is going to be defined as anyone who handles, uses, or conducts research using compressed gas cylinders, or those who are responsible for such action. So pretty straightforward, yes? Importantly, I want to point out that you can see that we've tried to think outside of the box of the laboratory itself to ensure that our programming captures the considerations of things like capital projects, our supply vendors, including Airgas, and other service providers, and of course, our EH&S staff. We are under the umbrella of the scope of this program. And so while the majority of the programming has been built for laboratory researchers, there is specific content for these other related stakeholder groups. And when we talk about the contents of the program in a moment, I'll point out some of what those are. So with that, I think we're ready to take a look at the content and the new program elements that are part of the Columbia University Compressed Gas Safety Program. So in brief, there are three main elements to the new program. We've developed a manual, a training module, as I mentioned, and a website. And all of these have been prepared and contain information based on a comprehensive review of applicable regulations, standards, and best practices. And we work directly with some of the most prominent users of some of the most hazardous gases on campus. We assembled many stakeholder groups in many different forums to discuss the contents and the particulars of the manual and the training program. And we worked closely with industry professionals as well, including those who are on the call, to develop and review this content so that we had second sets of eyes and third sets of eyes so that we could be confident that it is reflective of current and quality information. So let's take a look at each of these primary program elements in brief for just a moment. And starting with the manual, there are a few sections that are worth highlighting. And again, depending on your role and your day-to-day interaction with compressed gases, some or others of these may be more applicable to you, and you may find yourself referring to a different section or sections more than others. It's the equivalent of sharing a textbook, and some people put in their little note flags, and some other people will dog-ear the other pages that are important to them. The first three sections that I will mention were created by EH&S for the program, and their intent is to consolidate a lot of otherwise very complicated and very hard to find information about gases and how to use them in the lab. So the first of those is a summary table of compressed gas hazards. So this lists several commonly used hazardous compressed gases at the university, and it is a good resource for researchers to consult in order to understand the specific hazards associated with the gases that they're using. So a very simple, easy to read, easy to use table is what you'll find there at the summary table of compressed gas hazards. You'll also find a table of laboratory requirements for hazardous gases, which is another very, very useful consolidated table of information that's going to provide information regarding the necessary rules and regulations to follow while working with gases. So here you're going to find information about labeling, signage, storage, handling and moving, ventilation, and monitoring requirements for gases that exhibit specific hazards, whether it would be flammable gases, reactive, toxic, or oxidizing gases, along with regular inert compressed gas cylinders. So again, a very handy resource of consolidated information of laboratory requirements. From there, we also developed a vendor questionnaire for gas detection systems. So within that table of laboratory requirements, you might find that the use of certain gases in certain quantities will require monitoring or detection systems. So the questionnaire will provide detail on how to select a vendor when implementing a gas detection system. So this is a useful tool. Again, I mentioned the multiple stakeholders here, not just lab users. We could have people for whom this will be very useful in our capital projects group, or those who are working with them during a laboratory renovation, a move project, a new installation, or otherwise. So in addition to those, the manual also has several appended industry and regulatory documents that, again, have been helpfully collected into one place for your ease of reference. In there, we've added the Matheson, prominent gas supply firm, the Matheson Restrictive Flow Orifices Guide. So very technical, very specific, but certain gases do require this type of attachment, and here's a good resource to find them. The Compressed Gas Association electronic library contents that include technical guides and information regarding a wide variety of compressed gas safety topics, a table of New York City Fire Code, and then a vendor-based gas safety and material compatibility data chart from a company called Purity Plus that contains information regarding compatibility of gases and the materials involved in gas line and regulator connections. So obviously all very important and very useful documents to anyone who might be using or installing a compressed gas system. Beyond the manual itself, we've set up a website really as the main hosting point for all of the other useful tools, many, again, of which are from industry. There are instructional videos here, other technical documents that users might find helpful, including a video about the basics of cylinder handling. Again, this is from Matheson and has helpful tips regarding the handling, stabilization, and transportation of compressed gas cylinders. Other information that's linked here: there's a Matheson safety guide, the video, the guide to regulators, air gases guide to gas cabinet safety and code conformance, a tremendous resource that we consulted on a daily basis when we were putting together all of these materials. The handbook of compressed gases from the CGA, the Compressed Gas Association, and a couple of tools from NIOSH, a pocket guide to chemical hazards, and the compressed gas self-inspection checklist. I'll talk about that one more in just a moment. And then, as I've mentioned, the manual and website are great resources, and the next main program element, and the one that requires some homework for most or all of you that are on the call, is the training module. So this module will now be required for all compressed gas users in research. And again, as mentioned up front, today's session is not a substitute for completing the new training program. There's far greater detail contained within the module than what we can cover here today. And likewise, I want to point out, this is very important, the online module itself is not a substitute for hands-on training from an experienced user. So just as you don't learn to drive a car by reading a book and then jumping behind the wheel by yourself, it's important to understand that an experienced, trained colleague, or perhaps a vendor, is there to walk you through the hands-on functions that you'll be performing, whether that's changing regulators, strapping the cylinder to a wall, or other things that you'll do as a day-to-day user. So that training, again, can be provided by special arrangement through some of our compressed gas suppliers. Airgas is sometimes willing to assist with that, for things like attaching regulators, connecting supply lines, or otherwise operating or attaching other specialty apparatus. All right, so that's a very basic overview of the program elements themselves. And so while we're not going to go into great detail on the content of the training, I'm going to introduce a few important sections, starting with control methods that are going to be covered in the module. So within the training module, you'll find information related to the hierarchy of controls. And similar to other laboratory exposures, we can manage the hazards and risks of compressed gas handling through the application of the hierarchy of controls, and we often use these in combination. So this graph is likely familiar to everyone, but just to point out, when we start at the top of this inverted pyramid, or triangle rather, we're starting with the most effective control measures and working our way down toward the point toward less effective controls. And so, OSHA and other industries recognize that this is a means of identifying effective controls to protect workers from workplace hazards. And the application of this hierarchy minimizes workplace incidents, illnesses, injuries, and otherwise helps ensure that we have safe and healthful working conditions. So in keeping with that hierarchy, the best thing that we can do to manage exposures, and I don't want to put Airgas or our other guests out of business, but the best thing that we can do is eliminate the use of compressed gases and eliminate the risk altogether. So how does that work in practice for compressed gases? Well, a lot of it, if a compressed gas isn't needed in practice and in research, let's remove it. This is a lot of times a thoughtful evaluation, that should be done from time to time. And many times this takes the form of the removal of a cylinder that hasn't been used or needed for a significant amount of time. So, you have your cylinders that you use day to day. Those are needed. They can't be removed. They're there for certain purposes or uses in the lab. But maybe there's another cylinder in the corner that hasn't been used for 3, 4, 6, 10 years. What's it doing there at that point? If it's not needed, let's remove it. And along with it, let's remove the risk of it falling over. Let's remove the risk of it leaking or otherwise causing problems. So very simply, that's elimination and that's substitution. Substitution rather is, the exchange of one hazard for a less hazardous alternative. And this can mean gases themselves. Maybe an inert gas can be substituted instead of using a flammable gas. Or it can be substituting associated materials used with or around the gases, different types of infrastructure, different sizes of cylinders, or different tools that can otherwise make the use or handling of the gases safer. So from there, I want to mention, again, in brief, a few of the engineering controls that you'll find commonly associated with gases, and these are discussed in great detail in the manual, but just for purposes of introduction here, these are things that are designed to either remove or prevent exposure to a hazard. And for compressed gases, these are going to include things like the use of valves, regulators and manifolds, and even specialized exhaust systems such as gas cabinets. And you'll find these in some very specialty locations on campus already. And it might be that certain installations going forward will require specialized exhausted enclosures based on the type or the quantity of gases that are used. Next on the list as we work our way down that hierarchy are the administrative controls. And for gas systems, these often include monitoring and alarm systems. These are particularly important, as I mentioned earlier, to stakeholders whose interaction with the program involves the construction or renovation of labs or the installation of new equipment. And so going forward, the content of the manual will be treated as a design requirement for all gas installations. Wherever we're invited to and take part in discussions related to laboratory renovation, laboratory design, and we try our best to always have a seat at those tables, we will ensure that those design requirements are made aware to project teams and are met throughout the course of the projects. Another administrative control that's also extremely important in this context is checking on compressed gas systems regularly. And so an important resource that we've included in the program is a link to some helpful inspection guides, including the NIOSH self-inspection guide that I mentioned earlier. So that's a very straightforward checklist that laboratories can very easily include in their daily standard operating procedures to ensure that their compressed gas systems are operating correctly and safely. And finally, when it comes to controls, we arrive at the bottom of the hierarchy, our personal protective equipment, or PPE. So as everyone knows, PPE should never be used as a standalone control in the absence of other controls. And all users of compressed gas should have access to the standard protective equipment to minimize the risk of harm to their body, their face, their hands that we would otherwise find in a laboratory, the lab coat, gloves, and safety glasses. And then increased protection as needed based on the hazard should be layered onto that or otherwise adjusted as needed. And so that might include things like a face shield or tight fitting goggles for increased eye or facial protection. So the training program also does include information, as we mentioned, about the safe handling of compressed gas cylinders. And thankfully, we have our terrific partner in Airgas who do the bulk of the work in getting our gas cylinders in the door and into our labs. There are, of course, however, occasions where a cylinder needs to be moved from point A to point B once it has been delivered, and safe handling really is critical to injury and exposure prevention. The risk of damage to a cylinder goes up significantly during moving. So things like using a hand cart and removing valves and replacing caps during movement are really essential. And again, all of this is covered in greater detail in the training module. And finally, we certainly couldn't have a new and comprehensive compressed gas safety program without ensuring that emergency preparedness and response information was included. For purposes of today, we'll just have this slide to show the contact phone numbers for EH&S and for public safety at our various campuses. But within the manual, we have additional information on how to deal with a gas release, what to do if that release is or isn't in a chemical fume hood, what to do in the event of a fire, what to do in the event of an exposure to a compressed gas. So again, all of that in great detail available in the training materials and in the manual and other guidance documents that are part of the program. So as I mentioned up front, this program was developed with the input of many experienced and highly qualified users of compressed gases, again, as well as industry professionals. And many of them offered their own tips and instruction based on that experience. And there's really no substitute for that experience. So we felt like it would be helpful to include these notes for everyone's benefit. And they're also captured in the manual and in the training materials themselves. So you see things like using those CGA index numbers as a verification to triple check that you have the right regulator to match with the right cylinder. Protective caps when moving cylinders, the use of Teflon tape or not rather, when fitting regulators to cylinders, and other things that have been learned over the course of these users' experience that, again, we just felt like there was no substitute for their inclusion on the part of those users particularly. So with that, again, I want to thank my colleagues in EH&S. There have been many, many of them, too many to name here specifically today, who have been instrumental in preparing all of these program materials. I want to thank our other partners, including Airgas, and of course, thank all of you for joining the call today. And from here, the next steps for everyone really would be to access these resources and materials, take a look at them on our website, complete the training as users and assign that training to anyone in your lab. For those of you who are on the call who are principal investigators, assign that training to anyone in your lab who are compressed gas users, and then refer back to those materials as needed for your ongoing technical needs. And as always, please don't hesitate to reach out for EH&S for consultation with those technical needs. And so as a final thank you to everyone who attended today, and I've seen Lauren taking notes and trying, really scrupulously to keep track of everyone who's on the call, we have a token gift for each of you courtesy of Airgas, and we'll be using the attendance sheet from the sessions to deliver those to you in person. They are those stick-on cell phone wallets so you can slip a business card into or slip your Metro card into, however you like to use those. And again, that's courtesy of Airgas. So thank you, Katie and team, for those. And from there, we'll open it up to a couple of questions. Again, keeping in mind that today's session is an introduction and not a substitute for training. But if you'll give me a moment, I think I can unmute everyone now. Or actually, I'll leave everyone muted so we don't pick up a lot of background noise. But if you should have the ability to unmute yourselves if anyone would like to jump in and ask a question of myself, my EH&S colleagues, or the special guests, Katie, Keith, and Rob, who have joined us on the call. Let me also ask Katie, Keith, and Rob, if you have anything that you'd like to add, jump in, share, based on your experience, based on your knowledge, or anything else that you'd like to just make the Columbia University research community aware of when it comes to compressed gas safety.
I do. Thanks, Chris. That was a great presentation, covered a lot of good information. And I know you have all worked very, very hard, especially Lauren and yourself on this project. I just wanted to say, I was with Tech Air prior to Airgas for 28 years, and we were purchased by Airgas about a year and a half ago now. Airgas has a tremendous amount of resources when it comes to safety. We have an entire safety department. PPE, signage, all of that. I've got great resources for people who would be willing to put on seminars. Lauren and I have spoken about that briefly. So, you know, anything you can think of gas related, please feel free to reach out to me directly. You know, we can get involved with your capital improvement projects for lab refreshers. Make sure that, you know, piping is up to speed, that, you know, we can do lab audits to determine the health of your regulators that you're using, et cetera. But more than happy to help with any aspect of that. So anybody, you know, feel free to directly at any time.
Thank you, Katie, and thank you for your partnership over the years on all of that and more. And I think we had another question. Go ahead.
So Katie Barmack, so there are these the new training modules for compressed gases?
This is a new standalone training module that is available on Rascal. I apologize, I don't have the training course number off the top of my head. Perhaps someone else who's on the call remembers it. But yes, this is a new standalone training module on Rascal.
Okay, so it would be really helpful if you could email that to us so that it's, because when you go to Rascal, there's so many modules, it's even hard to know which one you should sign up for. The next thing is, if we want to do a lab audit with Airgas, how do you schedule that? Sorry.
So Katie, you can just reach out to me. Chris, is my contact information somewhere on this training, or would I need to provide that to the individual users directly?
Maybe you could type it into the chat box, Katie, that'd be great.
Sure,
and
absolutely.
obviously we all, you know, we have Katie's cell phone number. We try not to bother her, but you know, if anybody reaches out to us, we can always connect easily and directly with Katie to set up a lab audit. And I see a question from Mark Underwood in the chat box. And the question is, what steps are being taken to ensure deliveries are safe during COVID-19? That's without punting or with apologies for punting, I'll let Katie handle that as she works, you know, closely with her drivers and her logistics team.
Absolutely. So, I mean, Airgas obviously has taken safety during this whole COVID crisis very, very seriously. We check our employees every single morning. They are temperature checked before leaving our facility. They wear the required PPE, face mask, gloves. You know, if anybody sees anything differently, certainly reach out to me. And we also have to now provide I believe it's called an attestation form that has been provided to us. So that is filled out daily, and our delivery personnel have to carry that with them.
Yeah, so for everyone else on the call who's a Columbia Uni holder, it's a paper version of the Reopen CU app that we're all doing every day to get our green pass. All right, I see in the chat that both Kathy and Lauren were able to post the Rascal TC course code number. It is 5450 5450. That's the specific compressed gas course, the new module. And I see a question from Professor Marty Fleischer. Is there specific info in the new documentation regarding cryogenic liquids and gases from cryogenic liquids? Lauren, maybe you want to jump in and talk about the contents for cryogenic materials?
Yes, I just had to unmute myself there. Sorry, I was reconciling our attendance sheet. Yes, so we do have some information regarding cryogenic liquids, and we did include that in our gas manual. And I can connect with you, Martin, afterwards if you'd like regarding that, so I can send you the specifics.
Yeah, we covered them as kind of a special standalone category, particularly because there are some wrinkles related to FDNY regulations pertaining to cryogens and volume limits and monitoring and detection.
So we will take your question down and save that in our chat box, Martin, and we'll email you directly afterwards.
All right. So being mindful of everyone's time, I know it's 11:33. I think we're right at the 30-minute mark. We can stay on if there's other questions. A request from Norm Simpson to email that information also. We'll try our best to do that for everyone who's an attendee here. And I'll just, I'll leave it open for another minute if anybody wants to jump in with a last minute question. Otherwise, wanted to, again, thank everyone for joining. And again, remind everyone that they can always reach out to EH&S for any questions, comments, or concerns.
So Chris, I'm getting
There was a question in the chat box about the time frame for completion of the trainings. What is the expectation?
Ah, okay. Yep. There's a question from Drew. Do you have a time frame in mind for users to complete this training? Labs will surely want to know. I would simply say as soon as possible. We have trouble putting a hard deadline on anything like this, to be perfectly honest. So we would say as soon as possible. And, certainly for folks who are, this is a great time if folks are working in a hybrid fashion or working from home, that they do so before they return to campus or while they have time working in combination on campus and off campus. And then a lovely note of thanks from Christina Doyle to Katie to say how great Noah Calamari, their delivery tech, is. So thank you for pointing that out, Christina. And I think with that, we will say farewell to everyone. And again, thank you. Have a wonderful rest of your late morning and day, and be well and continued good health. Take care.
Thank you, everyone.
Thank you.
Thank you. Bye.